Once again, the component parts of the pump, including the motor, the pothead, the protector, the intake, gas separator, and the pump itself. Let's consider the pump first. Electrical submersible pumps are multi-stage centrifugal pumps. Each stage consists of a rotating impeller and a stationary diffuser, which we see here. As the shaft of the pump moves in response to the work being done by the motor, the impeller rotates, causing a rotating motion to the fluid. The diffuser changes the direction and velocity of flow and directs fluid from the impeller of one stage to the impeller of the next stage. The type of stage used determines the volume of fluid to be produced. The number of stages contained in a pump determines the total pressure or head generated. The horsepower required by the motor is determined by both the volume displaced and the head generated. Pumps are manufactured in a broad range of capacities to satisfy almost all well conditions. For any given pump, the impellers are designed to operate efficiently over a specific capacity range. As we see in this plot of pump efficiency versus pump displacement rate, if the pump is operated at too low a capacity, there is a downthrust of the impeller against the diffuser, causing wear on the bearings and washers. Conversely, if the pump is run at higher than design capacity, an upthrust of the impeller against the upper part of the diffuser will occur, causing similar wear. Ideally, then, the impeller should float freely during operation, and should do so over its recommended operating range. This is where the pump will work most efficiently. The length and diameter of a pump are limited by manufacturing and wellbore conditions. The length of a single section of the pump, because of assembly and handling difficulties, is limited to about 20 to 25 feet. However, it is possible to join pump sections together, adding successive stages to develop the required head. Pump diameters are limited by the size of casing in which they are to be run. Here, for example, we see the suggested pump diameters recommended for various size casings. Thus, we see that the 3 3/8 inch OD pump will fit very nicely within the 4 1/2 inch OD casing, and that if our casing is 8 5/8 inch or greater in diameter, then we could use 4, 5 1/8, or 6 3/4 inch pumps. The number of stages that can be added to a pump is not unlimited. There are three principal variables which must be considered when adding stages to a pump. They are the horsepower rating of the shaft that turns the pump, the pressure rating of the pump housing, and the capacity of the thrust bearing. Each of these is considered by the manufacturer when specifying the capacity range for a pump.